Hey there, myself Sanjana Revankar, a CS student in BIT Davangere. I and my friend Chahat Tandon will be giving you some information about GenSim and spaCy. So let's get started. GenSim. Let's elongate it. Gen is short for generate and sim is short for similar. GenSim is considered as natural language processing package, and GenSim is a open source Python library for NPL. Of course, it is said that it is topic modeling for humans, but it is more than that. So let's know more about GenSim. GenSim is a Python library developed and maintained by Radim Rehurek. GenSim package runs on Linux, Windows, and also on Mac. It is a leading and state-of-art package for processing text, working with word vector models, and for building topic models. These word vector models are the models that are used to produce word embeddings. Word embeddings are representation of words with similar meanings. And also GenSim is used for document indexing, similarity retrieval with large corpora. Here, corpora is a collection of similar documents or a large collection of text. Basically, GenSim's target is NLP and information retrieval community. Let's talk about features of GenSim. First is scalability. Scalability is nothing but processing capacity. So let's see how GenSim is scalable. GenSim can process large web-scaled corpus using some incremental training algorithms. It is robust. It's been 4 years and still it is being used in various organizations. I think it is strong and perfect, I guess. Platform independent. Since I told you earlier, it runs on Linux, Windows, Mac, and many platforms that supports Python and NumPy, converters, and IO formats. GenSim contains memory-efficient implementations and several data formats. These data formats can be used for input or output or convert between one another. Efficient implementations. The core algorithm in GenSim use really high optimized routines. I think that's why it is efficient. And of course, it is open source, such a wonderful library, isn't it? Don't you agree? Let's look at the core concepts. Um, Documents. Document contains unstructured data or just some text. It may be a tiny tweet or a long paragraph. Corpus. A corpus is a collection of documents or group of documents. It is an input for training model. During training, model uses it to look for common or similar words or themes of topics and initializes their internal training parameters. And documents to organize. Uh, that's it. After training, a model can be used to extract topics from new documents. Let's see about vectors. Vector is a mathematically convenient representation of document. To let's take an example, like to know the structure and or some metadata of our corpus to or to manipulate, we can actually approach a question answer pair. Like example here, like how many paragraph does a document has, that may be 4, or how many times does the word institute appear, maybe 7. This is one of the feature in vector of features. Next, look at the model. Since we have vectorized our corpus, we can model it. Models it is nothing but an algorithm for transforming vectors from one representation to another representation. Let's see where and why and where GenSim is used. They say GenSim is fast. Let's see how. GenSim taps into many low-level BLAS libraries, that is basic linear algebra subprograms, that's by means of its dependency on NumPy. And although GenSim's core is Python, it can actually execute high-level optimized Fortran or C under its hood, including multi-threading. It is easy to use because it is unsupervised. Memory wise, it is memory efficient because GenSim uses Python built-in generators and iterators that makes it memory efficient, and Python's design goal was to be memory efficient. Now let's see who all uses this GenSim. First is Amazon. You know, right, what is Amazon? It is a retail factory. Here, GenSim is used for getting document similarities. Next, National Institute of Health. Here, it is a health industry which uses GenSim for processing grants and publications with word to back. Cisco Security. It is a security industry uses GenSim for large-scale fraud detection. Next, 12K Research. It is media. Uses GenSim for document similarity analysis on media articles. Talent Pain. It uses GenSim for candidate matching in high-touch recruiting. Capital One. It is a finance industry. It uses GenSim for topic modeling for customer complaints exploration. Let's summarize GenSim. It is a Python library for topic modeling. It is an open source package, unsupervised, mainly used in natural language processing and information retrieval community. That's all, folks, about GenSim. spaCy will be explained by my friend. Thank you. Happy learning.
Hello everyone, I am Chahat Tandon and today we are going to talk about spaCy and industrial strength NLP. If a normal data analysis tools in Python for tabular and structured data has pandas, then the data analysis tools in natural language processing for text and unstructured data has spaCy. You see, when you're first starting out as a data scientist, chances are you'll be dealing with structured data, but which doesn't necessarily need spaCy to handle complicated text data depending upon your needs. In most cases, pandas will fit your use cases. But once you start dealing with unstructured text data, basically NLP stuff, where this is no longer applicable or handled by pandas, that's when spaCy comes in. Let's have a look at what it is. What are NLP and spaCy? Natural language processing is basically reading and understanding of spoken or written language. It is word recognition, automatic translation of one language into another, and automatic answering of questions. What is spaCy? It is a C extension of Python designed to give C-like performance to Python programs. Hence, it is quite fast library. spaCy provides a conscience of APIs to access its methods and properties governed by trained machines and deep learning models. spaCy is a free open source library for advanced NLP in Python. It contains pre-trained statistical models, word vectors, and it currently supports tokenization for about 50 plus languages. To install spaCy, all you need to do is type the following command: pip install spaCy. spaCy, its data, and its models can be easily installed using Python package index. Let's have a look at some of its features. Tokenization. Tokenization is segmenting text into words like punctuation marks, full stops, etc. Parts of speech tagging. It is assigning word types to tokens like a verb or a noun. Dependency parsing. It is assigning Dependency labels describing relationships between individual tokens like subjects or objects. Lemmatization, assigning the base forms of words. For example, the lemma of word was can be be, or the lemma of rats is rat. Interest is interesting, interested, anything. Named entity recognition, labeling named real world objects like persons, companies, locations come under this category. Sentence recognition, similarity. Similarity is comparing words, text spans, and documents to each other and figuring out how similar they actually are. Text classification, assigning categories or labels to a whole document or parts of documents. Training, updating and improving a statistical model's production comes under training. Processing pipeline. When you call NLP on a text, spaCy first tokenizes the text to produce a doc object. The doc is then processed in several different steps. This is also known as the processing pipeline. The next is training model. spaCy's models are statistical and every decision they make, for example, part of speech tag to assign or whether a word is a named entity or not, that is all a prediction. This prediction is based on examples the model has seen during its training. To train a model, you first need training data that you want the model to predict. This could be a part of speech tag, a named entity, or any other information. The model is then shown unlabeled text and it will make predictions. Because we know the correct answer, we can give the model feedback on its predictions in form of a gradient that calculates the difference between training examples and the expected output. The greater the difference, the more significant the gradient and the more accurate a model will be. Let's have a look at an example. We are using a Docker container on mybinder.org to execute this piece of code. First of all, we install spaCy. We import the required files. The text we are using is given in the form of a document. So doc equals NLP text. We analyze the text. We want to differentiate them as nouns or verbs. So after doing this, we can run the code. The output is shown here. Noun phrases contain Sebastian Tron, that can be a name. Self-driving car, that's a noun. Google, a proper noun. Few people, company, I, you. Pronouns are also included in noun phrases. For verbs, we have start, work, drive, take, can. These all. So we can see that spaCy works on a higher accuracy rate. Here are some benchmarks over the years. In the starting, it used C++, then Java came into picture, and right now, Python and Python with the accuracy of 92.6%. Let's summarize what we have learned. spaCy is used for text summarization. It is an industrial strength NLP because it focuses on providing software for production usage. The basic idea for creating a summary of any document includes text pre-processing, which is basically removing stop words and punctuations, word frequency distribution, number of times each word appears in the document, priority based on how many times a word has occurred in a document and the frequency table, build summary by joining each sentence above a certain score limit. Thank you.